Hello friends, how are you? I hope you will be fit and fine. So today we will discuss the most important chapter of physics that is known as semiconductor. In semiconductor, our first topic is Band's theorem. According to Band's theorem, it says that in any solid there are two types of band present. First one is valence band, second is conduction band. Valence band in which electrons filled in valence shell is known as valence band. Conduction band. Conduction band in which no electrons are present in valence shell is called conduction bands. Next one is forbidden energy gap. The gap present between the valence band and conduction band is known as forbidden energy gap as shown in the figure. Next one is classification of material on the basis of energy bands. First one is conductor. In case of conductor, the forbidden energy gap is 0. Valence band and conduction bands overlap. As shown in the figure, some electrons from valence band can easily pass into the conduction band. This free movement of electrons is responsible for the conductivity of metals. Next one is insulator. The valence band is completely filled with electrons and the conduction band is completely empty as shown in the figure. The energy gap between valence band and conduction bands is very large. Next, semiconductor. The valence band is completely filled with electrons and the conduction band is completely empty. As shown in the figure, there is small energy gap between valence band and conduction band. The best known example are silicon and germanium. Now conductor, insulator and semiconductor on their basis of conductivity. Conductors are the material which allow electric current to pass through them. They have low resistance. Examples: all metals are good, copper, iron, silver, etc. In next one, insulator. Insulators are material which do not allow electric current to pass through them. They have high resistance. Example: rubber, plastic, air, paper, etc. Semiconductors. Semiconductors are material which have conductivity high than insulator but less than conductor. Example: silicon, germanium. Thus, if we give the temperature of value absolute 0, then conductivity of semiconductors is 0. If we increase the temperature, then conductivity of semiconductors is also increases. Next one is atomic structure of atom as you seen in the image. Orbits, K cell and L cell, M cell, electrons and nucleus present inside. Intrinsic and extrinsic semiconductors. A semiconductor in the pure form is called an intrinsic semiconductor. For example, silicon and germanium are two important examples of intrinsic semiconductor. A semiconductor doped with impurity is known as extrinsic semiconductor and the doping process of adding impurities is known as doping. The doping of a semiconductor increases its conductivity. Next one is impurities are two types: pentavalent and trivalent. Pentavalent, each atom have 5 electrons. Example are phosphorus, arsenic, antimony, etc. Next one is trivalent, each atom has 3 valence electrons. Examples of boron, aluminium, gallium. PN junction diode, a single crystal of silicon or germanium which has been doped in such a way that half of it is a p-type and the other half an n-type semiconductor is known as PN junction diode. In other way, we can say that the joining of n-type semiconductor and p-type semiconductors is known as PN junction. This is the symbol of PN junction. Depletion layer, the region AB in the vicinity of junction which has been depleted of free charge carriers, electrons and holes and has only immovable ions is called depletion regions. Immovable ions that cannot be moved. The potential difference between two sides of the depletion layer is known as potential barrier is VB at the junction. So biasing of the PN junction diode, first one is forward biases. The PN junction is said to be forward biased if the positive terminal of the battery is connected to the p-type semiconductor and the negative terminal is connected to n-type semiconductor. In p-type semiconductors, the holes are present and the n-type semiconductor electrons are present. If their positive charge are repels and negative charge are they push up them and the depletion rate is decreases. Next one is reverse biases. The p-n junction diode is said to be reverse biased if the negative terminal of the battery is connected to the p-type semiconductor and the positive terminal is connected to n-type semiconductors. In p-type semiconductors, the holes are present with positive charge and n-type semiconductors have electrons with negative charge. So positive and negative charge are attractive equally, so therefore flow of electrons and depletion rate increases. Thank you friends. If you like my videos then subscribe my channel and press the bell icon please. Thank you friends.